Good morning. My name is Miriam Benitez and I work in the University of Valencia with Professor José Vicente Roslis. I'm going to present our research called a nanoformulation of an insecticide based on azadiractin coming from neem. In our region, the main crops are kaki and citrus, and the principal pests of these crops are mealybug, thrips, and citrus whitefly. Due to the restrictions in the use of pesticides, we need to develop new substances. Now, scientists are focused on essential oils as pesticides because of its lower toxicity. They don't affect vertebrates, only affect the target pest. They are very potent in low quantities and they decompose quickly. So, among these essential oils, the neem oil has a great potential. It comes from the seeds of the Asian tree Azadiracta indica. The most important metabolite is the azadiractin. The characteristics of this substance are the hormonal inhibition in insect shedding, so it's able to avoid the step from the larva to the adult. It's repellent too, and of course don't affect the vertebrates. The disadvantage of the product is the degradation by UV rays of the sun and temperatures. So we have put this substance inside nanomaterials, silica matrix, which can be modified with titanium atoms to avoid the sun effect. The idea is to put a sunscreen on the product. So, what am I talking when I say nanomaterials? We measure humans in meters. Smaller things like flies are measured in millimeters, but a nanometer consists in a split a millimeter 1,000,000 times. The use of nanomaterials in agriculture is already known. We use nanostructure for the controlling release of substances like fertilizers and biocides. Nanomaterials can be used also as fertilizer or as a method to improve crops. Two, it is possible the use of nanomaterials with phytopathogenic species that could be microorganisms and insects. And nanomaterials could treat and monitor the water and contaminated soils. With all of these ideas, we have prepared different materials with different size and shapes. They have higher superficial areas. In the case of zero gel, the superficial area is low, but it has big pores to get different organic substance inside. UVM7 was developed in our research group and has a dual system of pore really useful. When we load the neem oil in our nanomaterial, only the UVM7 gives us good results. In the table, we can observe the percentage of loading of A26. That it is the commercial insecticide with a 2.6% in azadiractin. The gold NO is the neem oil with an unknown content in azadiractin. On the aza, which is the azadiractin with a 98% of purity. There are three materials, UVN7 with titanium atoms, and silica fume. Silica fume is an amorphous material. We modify these three materials in the surface with amines and methyls groups in order to improve the neem oil loading. But as we can see, the best results are with the UVN7 without any change. Another modification was the introduction of cyclodextrin groups. A cyclodextrin is an organic molecule. It has a base shape and inside it can accommodate bulky groups. But in this case, the cyclodextrin obtaining the worst loading. To finish, we have made field tests with Dialeurodes citri and Eutetranicus bansky. In the case of the Aleurodes C3, we are ending the analysis of the data, and we are bending of an additional validation test. In the state larval 1, the material shows a similar effectivity to the commercial azadiractin, and it is effective for 7 days. But in the state larval 2, the material shows a higher effectivity than commercial azadiractin, and also it is effective for 7 days. Titania doesn't improve the essential oil, and the test with Eutetranicus bansky is still in progress. The Essence N project is granted by Generalitat Valenciana in the framework of the Program of Rural Development from the Comunitat Valenciana. Also is granted with the Ministry of Agriculture of Spain and the European Union. Thank you for your attention.